Hello students, today I am going to discuss about rate constant of a chemical reaction, its characteristics and the units of rate constant. Okay, please listen. Rate constant. Rate constant of a reaction is also known as specific reaction rate. Its symbol is K. Okay. For a general reaction, A moles of A reacts with B moles of B, forms some product. Its rate law is, we know, rate is equal to K into molar concentration of the reactant A raised to X into molar concentration of the reactant B raised to Y. When molar concentration of A equal to 1 molar and molar concentration of B equal to 1 molar, then the observed value of rate is equal to rate constant. That means the rate constant means what? Rate constant is the rate of a chemical reaction. Rate constant is the rate of a chemical reaction when molar concentrations of all the reactants become unity. Rate constant is the rate of a chemical reaction when molar concentrations of all the reactants become unity. Then we will see about characteristics of rate constant. Characteristics. Number 1, K has a definite value for a reaction at a particular temperature. K has a definite value. Value for a reaction at a particular temperature. That means what? The second point, different reactions having different value of K at a particular temperature. Different reactions having different value of K at a particular temperature. And third point, the value of K depends on temperature. That means the temperature changes, the value of rate constant also changes. And the fourth point, very, very important, the value of K independent of initial concentration of reactants. And the next point, the value of K is a measure of the speed of the reaction. That means greater the value of K, faster is the reaction. These are the main characteristics of rate constant. Okay, next, units of rate constant. Please listen. Units of rate constant for a reaction for an nth order reaction, we can consider nth order reaction. Suppose R gives P, the reactants converted to products. Okay. Nth order reaction. For this reaction, the rate law is rate is equal to K into molar concentration of the reactant raised to N. Okay. Then the value of K is equal to rate divided by molar concentration of the reactant raised to N. We know the unit of rate is mole liter inverse second inverse, and the unit of molar concentration is mole liter inverse whole raised to N. Okay, this is the form of x raised to m by x raised to n. Here the power is 1, power of mole liter raised to minus 1. Here the power of mole liter raised to minus 1 is n. Then it becomes mole liter inverse whole raised to 1 minus n second inverse. That means mole raised to 1 minus n liter raised to n minus 1 second inverse. Then for the nth order reaction, the unit of K is mole raised to 1 minus n liter raised to n minus 1 second raised to minus 1. Mole raised to 1 minus n liter raised to n minus 1 second raised to minus 1. Then if the order of the reaction is 0 order reaction, unit of K is, for 0 order reaction, the value of n equal to 0, then mole raised to 1 minus 0 means mole liter raised to 0 minus 1 means minus 1 liter raised to minus 1 second raised to minus 1. Then for a first order reaction, the unit of K, for first order reaction, here the value of n equal to 1, then mole raised to 1 minus 1 means mole raised to 0 means 1, liter raised to 1 minus 1, liter raised to 0 means 1, that means second inverse. That is, time inverse is the unit of rate constant for a first order reaction. Then second order reaction, the value of n equal to 1, then mole raised to 1, the value of n equal to 2, then mole raised to 1 minus 2 means mole raised to minus 1, liter raised to 2 minus 1, liter second inverse. Then for a third order reaction, mole raised to 1 minus 3, mole raised to minus 2, liter raised to 3 minus 1, liter squared second raised to minus 1. Okay. Already I told you, rate constant of a chemical reaction. For a reaction, A moles of A plus B moles of B gives product. The rate is K into molar concentration of A raised to X into molar concentration of B raised to Y. When molar concentration of A equal to 1 molar, molar concentration of B equal to 1 molar, then rate equal to rate constant. The rate constant is the rate of a chemical reaction when molar concentrations of all the reactants become unity, and its characteristic. K has a definite value for a particular reaction at a given temperature, and that means second point, the second characteristic, different reactions having different value of K at a particular temperature. The value of K depends on temperature. Okay, when temperature changes, the value of rate constant also changes, and the value of K is independent of initial concentration of reactants, and the value of K is a measure of the speed of reaction. greater the value of K, faster is the reaction, and units of rate constant. For a nth order reaction, R gives P, its experimentally observed rate law is rate equal to K into molar concentration of A raised to N. Then K is equal to rate divided by molar concentration of A raised to N. That means the unit of rate is moliter inverse, second raised to minus 1, molar concentration of reactant unit moliter raised to minus 1, all raised to N. That means for nth order reaction, the unit of K is mol raised to 1 minus N, liter raised to N minus 1 second inverse, and zero order reaction, the unit of K is moliter inverse, second inverse, first order, second inverse, and second order mol raised to minus 1, liter, second raised to minus 1, and the third order reaction, unit of K is mol raised to minus 2, liter squared, second raised to minus 1. Okay? Yes. My next class I will discuss about integrated rate equations of rate constant for a zero order reaction and first order reaction. Okay? Goodbye.